let's see the quiz 4 and go step by step together. So the thing is, the professor showed us the tableau and asked us to start making the necessary iterations in order to find the optimal solution. So in this case, we noticed a typo yesterday. So like we are going to ignore one of those columns, X3 columns that are repeated. So here, let's just go back. We have in the rule 0 the z value and the coefficients of each one of the variables, including the surplus, the slack variable, sorry. So what that means, this first row here, how can I represent this in a problem? So I know it's a maximization problem because when we have the tableau, we assume that we have already transformed the minimization problem into a maximization problem. And also we can see here that all the surplus values are in the standard form, that is one for the first tableau. So it's 1 and in one of the rows and 0 in all the others. So now we know that we are in a regional, feasible region of our problem. And because of that standard form for the slack variables, and also, so we know that those are the basic variables in this iteration, and the non-basic variables that are equal to 0 is the x1 and x2. And we know that because of the form they present themselves. So they are not in this form of 1 and in one row and 0 in all the others. Sorry. So now we know that it's a maximization problem, that is maximizing z, 3x1 plus 2x2. That it's going to be z minus 3x1 minus 2x2 equals to 0. That's what we have represented here. So we have that it's z equals to 1 minus 3x1 minus 2x2 equals to 0 in the right-hand side. Okay, now we can go to the row 1. And in the first row, we will have our first constraints represented. And our first constraint is 2x1, 1x2, 1x3, plus the slack variable for the first constraint. Sorry, that's it. It's 2x1, 1x2, and 1 for the first slack variable that corresponds for our first constraint. And the right-hand side, it's 100. So how can we represent that in equations? Is it would be like this: 2x1 plus 1x2 plus 1x3. That in this case, I'm going to just put S1, that it's the slack variable, and this is 100. So in the original problem, this would be 2x1, 1x2 minus lesser or equal than 100. Okay, and we can now work in the row 2 and 3. That is going to be the same thing. I'm just going to input the numbers here to know that it's. So here I'm going to add 1 for the slack variable of the second constraint, And the other one is going to be just 1x1 and the slack variable for the last constraint, the third constraint. And this would be, instead of that, and in the original problem, it would be like this. So these are our three constraints in the original problem, and this is our objective function. And that's what we can see here. And in this first tableau, we can take that information doing the opposite, doing the procedures in the opposite direction that we would normally do. We also can identify what are the basic variables and what are the non-basic variables. And that's the way I explained it earlier. So I know the basic variables are the ones that have some value other than zero attached to them. So I know that x3 is the first slack, and it has this form over here. So it is one of the basic variables. X4 is also another basic variable because it has this format here, and the X5. So we know those three are our slack variables. A word additional to the problem, so we can make an equality instead of an inequality, and we can use the simplex to solve our problem. Now with that information, we can start to verify which are going to be the variable that are going to enter on my basis, and substitute one of those variables. And that's what another decision that I'll have to make, which variable is going to leave my basis. So first I have to understand and identify which variable are contributing the most for my objective function in this tableau. And how do I see this? I see the one that has the most negative value, the greater negative value. In this case, it's going to be the x1, because since it's the first tableau, that it would be easy for you to see that in the original problem, because an increase in x1 will increase 3 times my z, and increasing x2, it's going to just multiply 2 of anything that I add to x2. So it would be better for me to put some value in x1 without considering the constraints. So that's the direction that the algorithm is going. So, and that column over here that represents this x1 that is going to enter the basis are the pivot column. And now I have to find the pivot row so I can find the value, the pivot number. So I can start making the row operations, the elementary row operations to these equations, to the tableau. So I can start adding some values to one equations and taking some values of other equations and making something that it's more than 0 in my z. So, okay. For me now to find out what is going to be the variable over here in the basis that is going to leave to give me space for me to increase the x1, I will have to make the ratio test. So the ratio test is just the division of the right-hand side by the value, the correspondent value here in the column of the variable that I want to enter the basis. So in this example, I have that it's 800 divided by 1, 100 divided by 2, and 440 divided by 1. And that will give me those ratios. And also what that represents. What's happening here is that I have in my Slack variables all the value that I can. So in my first Slack variable, over here, I added 100. So x1 and x2 is 0, and x3 is 100. In the second, so let's put that in here, x3 is equal to 100. And I can see that information because I see here that it's 1, 0, 0. Okay, so I know this is the one that is in the basis, and the value that is associated with my 1 here is 100. So I know that I have 100 inputted to the x3. So x3 is equal to 100. Now x4 is equal to 80, and x5 is equal to 40. And that means this here is 100, so x1 and x2 is 0, x1 and x2 is 0. So for this equality to be true, x4 has to be 80, and x1 plus x5 equals to 40. If x1 is 0, this equality to be true, x5 has to be 40. And that's exactly what's happening here. So now what I want, I found out that for me to add x1, that I will increase faster my z value. I want to put, I want to know how much can I put in x1, and then I will have to go and see the constraints. And the constraints that are limiting most the number that I can put in x1 is the last one, because it's the smallest one. It's the one that I can only put 40 in x1. Because here, if I take off like x2 0, x4 I could put 80, and in here the first constraint I would be able to put 50, because I would in x1 I would have 50 here, so 2 multiplied by 50 would be 100. But the thing is, if I put 50 here, this one would not be valid. So that's why we make the ratio test, because we want to know what's the maximal value that we can associate with x1 in order for all my constraints to still remain working. Like I'm still respecting all the constraints. So that's why we have to choose the smallest positive number that we find here in the ratio test. So here's non-basic variables, and here are my basic variables. Okay, now I know that I'll have to eliminate my x5 to add my x1. So in order to do that, I have to make some row operations, elementary row operations, to my pivot number in order to eliminate all the other values over here. So I want this x1 to become exactly like all other basic variables. In practice, that's what I want. So this will become the basis. Okay, now I took off the x5 and I'm adding the x1. And for this to be in the standard form, I will have to have this value, the pivot number, as 1, and all the rest, it's going to be 0. And so the pivot number is going to be 40, and the rest is going to be 0. It's not going to have any value. So in order to do this, how can I change the x1 to add to the other row in order for this to be 0? That's the thought that we have to have. So this one is pretty simple. I have the row 3, right? And I have the row 3, and I can just multiply it by -1 and add to the row 2. And when I do this, let me copy this. So when I multiply this, so every multiplication or division that you make, it's had to be in the row that you are working, like in the pivot number, in the pivot row. And then you just add the other row. Now I have 0, that's fine. I will have to do this to all the other columns in this row. Now, for us to transform this 2 in 0 by adding x1, I can multiply, x3, so I can multiply by 2, r3, and add r1. For me to do this, I will multiply by 2 plus this one. Of course, this doesn't work because it's -2. And I will do the same thing for all the other columns in the row. Now the last one, for the row 0, I can multiply the row 3 here, right? I will multiply this pivot number by 3. So like 3 multiply by 3, and I'm going to add the row 0. And that operation is going to be 3 r3 multiplied by 3 plus the row 0. And I have 0, perfect. And I'll just add all the rest. So what happened here now is that now the x1, I know the x1 is a basic variable, is in the basis. And I know the x1 now had the value of 40. The other variables that are in the basis are x3, and we know, and we kept it, and the x4. And each one will have these new values over here. So now I know that z here, see, z is 120. Z equals to 120. Then x1, it's going to be 40 here. x2 and x3, no, sorry, x2 is going to be 0 because it's an x2 is going to be 0 and a basic variable. x1 is going to be 40. x3 is also a basic variable, so it's going to be 20. And x4 is also a basic variable, and it's going to be 40 over here. And x5 is some non-basic variable that we can see here. And so non-basic variable is going to be 0. So now I have z, and I have my non-basic variables and my basic variables and the values associated with each. But if I see the row 0, I see that I still have some negative constraints. And what that means is that I can still improve my problem. I can still make some changes. In this case, add x2, some value to x2, in order to increase my objective function, because I still have something to give. What gives me this information is the negative number here. So every time that I still have a negative number in the row 0, I will be able to add that column to the variable that are represented by the column to the basis and increase my objective function. So that's what we are going to do. We are going to try now to increase the objective function in inserting x2 to the basis, but now I have to know what variable there are in the basis I will be able to take off. And for that, we have to make the ratio test again. So the ratio test is going to be the new right-hand side divided by the value that we found in the column over there in the pivot color. Okay, this is undefined. If it's undefined or negative, we ignore it. We are just considering always in the ratio test the positive numbers, and it has to be the smallest positive numbers that it's the most limiting constraint, that represents the most limiting constraint. In this case, it's the first row, and so we are going to add the x2 and remove the x3 to give space to the x2. So now again, we have to make some elementary row operations in order to make x2 enter the base. So we have this number here that it's our pivot number, and the other numbers in this column we have to make become 0. Let's do it. So the row 0, 1, we don't need to do anything. We're just going to repeat ourselves and put like, it's going to be the same because it's already 1, exactly like we want it to be. Now, for us to transform this number here in 0, what we can do is just multiply our 1, that is our pivot row, so the one that we can multiply by -1 and add to the R2. So here we are multiplying this pivot number to -1, and I'm going to add to the number in the R2. And here 0, great. I'm going to do the same operation to all the other columns in this row. And I will have now to modify the last row, but the last row is already 0. So we can just repeat this. We don't need to make any other operation to that, transform this row. Fine. So the last one that we can make any modification is the row 0. And so the row 0 we have we can multiply the R1 to 2, right? And add to R0. And that will become our pivot number multiplied by 2, add it to the row 0. It's 0 exactly as we want it to. So we are going to extend the operation to all the others. And what we found now is that our z value increased as we expected it to. So our z value now is 160. Our non-basic variables are different now, right? Because I enter in the place of x3, x2. So our non-basic variables are x3, that is equal to 0 here, and x5, that is also equals to 0. x1, x2, and x4 have some numbers associated with that, and we can find that those numbers in the right-hand side. So x1 is 40, didn't change. X2 is 20, and x4 is also 20. Always take these numbers and put in our objective function, just to be sure that we are making this the right calculations. So x1 being here 40, it's going to be 120, and x2 being 20, it's going to be 40. So 120 plus 40, it's going to be 160. So it kind of is an indication that we are in the right direction. Z's, I'm calculating z correctly with those basic variables that I have over here. But now we still haven't reached the optimal because we still have a non-negative value, a negative value here. I still have a negative value in x5, which means that I can include x5 in order to improve my z value. So I know that this column is going to be the pivot column, and I'm going to make the ratio test in order to find out which are going to be my pivot row. Okay, now I have that this one is not going to be considered because it's negative, but these two are positive numbers, and we are going to choose the one that it's the smallest number, right? As we did before. So this is our pivot row, and these are our pivot column, and this is the pivot number. So we have to make the row operations all over again in order to be able to add this to our basis x5 to be added in the place of x4 over here. So the pivot number is correct. I don't need to make any modifications. So I'm going to repeat the row 2, and I'm just going to repeat the row 2 and the calculations that I'm going to make over here. So here, here, here. Okay. So it's the same numbers. Now to the row 3, I can only R2 multiply by -1 plus they are 3. It's the operation that I need to transform this row 3, this number here to 0. So is going to be this multiplied by -1 plus this value over here. And I'm going to do the same thing for all the other columns. Now this one I can always do like R2 multiply by 2, right? And add to R1. And then I will have the row 1 that I need. So this multiply by 2 plus the row 1. Now it's 0 like we wanted, and let's do the same to the others. And the last one is the row 0, and the only thing that I need is to sum both. So I can sum R2 to R1, sorry, to R0, and I will make this 0, and the rest I'm going to find. So what we can already see here is that my z value increased, right? And another thing that we can see here is that I have no negative numbers here in the row 0. So which means that we reached optimality. So z equals 180 is my optimal value. And my non-basic variables are going to be the x, let's see here, the x3, again, because it doesn't change this, and the x4 that I added now. And my basic variables are going to be x1, that now has the value, x1 is over here, see? And has a value of 20. My x2, the now x2 that's over here now has a value of 60, and my x5 over here that has a value of 20. So that's my final and optimal solution, and that's how I do the simplex algorithm. That's how I make all the iterations necessary to find my optimal value. And always remember that all the multiplications or divisions that you make, you have to make only to the pivot row. And always focus on getting the pivot number as 1, and all the other numbers in the pivot column needs to go to 0. And think, which operation will I have to do to sum these two rows in order to get the numbers that I need.